So in this video, I'm going to go over the last problem in the KSP lecture. And I would encourage you to try the problems first and then maybe watch this video and see which things you need further explanation. So this is a problem from the 1985 AP exam on KSP. So they will give you the KSP values. That's something you're not going to need to worry about. And then they're going to ask you to find what we call the molar solubility of each one of the solids. So this is strontium sulfate. So again, molar solubility just means molarity of each one of those ions. And they will usually be pretty specific on the AP test to do it in pure water. So I'm going to write the equation. So strontium sulfate is breaking up into strontium ions and sulfate ions. And these are aqueous. So again, what we're looking at is if we had this in a beaker, I have some strontium and some sulfate floating above the PPT that is made, so the strontium sulfate solid down here. Again, they will usually draw it on the bottom of the beaker or the container. And then what you have is a little bit of these ions floating around in there in the aqueous solution. So we want to know how much we have in there. So our KSP is, of course, going to be our concentration of our strontium ion and our concentration of the sulfate ion, and they are multiplied together. So again, they use S's. You could use X's. They're not going to care. My KSP value for this one is 7.6 times 10 to the negative 7th. So this is going to be an S squared situation. So you're going to take the square root of that number. And so you're going to get S is equal to 8.7 times 10 to the negative 4th molarity. So that's going to be the concentration of your strontium ion and also the sulfate ion because they are in a one-to-one relationship. So the second one is the other ionic solid, strontium fluoride. Again, same kind of idea. So I'm just going to write this out. Only difference here is you have two of your anions. So you're going to have twice the concentration of that floating around in the solution. So again, if I draw the beaker over here on the side, here is your precipitate on the bottom, and then above it you have some of these ions, very little. But what you need to understand about this beaker is you're going to have twice the amount of fluoride in there. And so that's going to affect how we set up the equation. All right, so we have our KSP expression, strontium times the fluoride, and that's going to be squared. So this is going to be S, and this is going to be 2S. And again, it feels very redundant, but that is twice the concentration. This has to do with, this is a 1-to-2 relationship from the balanced chemical equation. So I have 7.9 times 10 to the negative 10th is equal to 4S cubed. 4S cubed. So I divide that by 4 and take the cube root. So S is going to be equal to 5.8 times 10 to the negative 4th. So that's going to be my concentration of my strontium ion. Okay, just an S. But what's going to be my concentration of the fluoride? Okay, what's going to be the concentration of fluoride? Well, it's going to be 2 times that number because I have twice the concentration in that beaker. So that's going to be around 1.2 times 10 to the negative 3rd is going to be your concentration of the fluoride ion. Okay, so that's an example of 2 straight up KSP type problems. And that'll be the maximum they do in terms of the calculation. They'll just go to a 1-to-2. They're not going to go to a 1-to-3. So a more complicated problem is probably this one. So if I have an aqueous solution, let me just refocus this. If I have an aqueous solution of strontium nitrate, is slowly added to a 1 liter solution containing 0.024 moles of fluoride and 0.01 moles of sulfate. You could assume that adding the strontium nitrate does not affect the volume. It's always going to be asking which salt precipitates first. What is the concentration of the strontium when the first precipitate forms? Okay, so I'm going to draw a picture over here on the side so we can kind of get a understanding of what this is going to look like. So over here is my beaker. So in here I have fluoride ions and I have sulfate ions. And I am adding the strontium nitrate. Well, the strontium is the only thing that's going to make a precipitate, so the nitrates never make a precipitate. So my concentration of the fluoride is 0.02, my concentration of the sulfate is 0.1. So the question is, which precipitates first when the strontium is added? So again, my strontium sulfate has a KSP of the 7.6 times 10 to the -7, so I'm just going to rewrite it from the first page. And strontium fluoride is 7.9 times 10 to the -10th. So since these are not both 1-to-1, I can't just compare the KSP, so that's why you have to do a little bit more digging. So strontium sulfate, I know 7.6 times the -7th is essentially my threshold. So I have to hit that number when I multiply the two ions in order to see if I get a precipitate. So strontium, how much do I need? If I have 0.1 molar of my sulfate. So again, that is the concentration of that anion. So I want to know how much strontium I need in order to make that precipitate. So easy math, strontium is going to be equal to 7.6 times 10 to the -6 molarity. Okay. So once I hit that, I will then start to make strontium sulfate. So once I hit that concentration as the strontium is added. So I got to look at the strontium fluoride then. So that is 7.9 times 10 to the -10th. So I want to know the strontium, how much of that do I need to reach that number if I have fluoride being 0.02 molarity. So that is the total molarity of the fluoride, so I'm not multiplying that by 2, but I am going to square it because, again, this is a 1-to-2 relationship, and from the breaking up of the fluoride, you would have that. So I square that number divided into this number, and the strontium that I would need in order to make strontium fluoride is about 2 times 10 to the -6 molarity. So comparing the numbers, okay, this number here, 2 times 10 to the -6, is smaller than 7.6 times 10 to the -6. So if I'm adding the strontium slowly, I would hit this concentration first besides this. So the strontium fluoride would precipitate first. Okay, that would be the first precipitate because I have the lower molarity of the strontium being done first. Okay. So what is the strontium when the first precipitate forms is going to be the 2 times 10 to the -6. And why that's important is going to be seen in the next problem. So if this is the most complicated of all of these, if more strontium nitrate is added, a second precipitate forms. So again, we know now that the second precipitate is going to be the strontium sulfate. Okay. So strontium sulfate. At that stage, what percent of the anion of the first precipitate remains in solution? Okay, so I'm asking about the F minus. So what do I have in that solution once that second precipitate starts to form? So I know I need to reach for the strontium in the second precipitation. I need to hit this mark. I need to get 7.6 times 10 to the -6 molarity. So that is what we calculated here in this problem. So I want to know if I start to get to that concentration, I will get the next precipitate to form. So the strontium sulfate starts to form. So I can go back to the strontium fluoride and say, okay, well, if I know 7.9 times 10 to the -10th is my threshold for this precipitate, and I know that 7.6 times 10 to the -6 is the concentration I need of the strontium in order to make the strontium sulfate, and I know this is very convoluted, what is the amount of fluoride I actually have in there? Okay, because again, the fluoride is going to be essentially being used up to make this precipitate. But now as I start to make the second precipitate and I add more and more of the strontium, how much fluoride do I actually have? So the fluoride comes out to be about 0.01 when you do the math here to make the first precipitate. Okay, using this equation. So if I started with 0.02 molar of my fluoride, okay, if I started with that amount, and this is essentially how much I used to make the first precipitate, 0.01, I have 0.01 molarity left of my F minus, okay? How much of that in terms of a percentage? Well, again, 0.01 molar over what I started with, which is 0.02. If I multiply that by 100, I get about a 50% of the anion. Now, again, there's another way to think through this problem, and if you have a better way to kind of explain it, this just seems to be the most straightforward of how to calculate the fluoride, but if you find a better way, that is acceptable as well.